All right, let's do a couple examples of solving rational equations. And this is going to come back to the idea that we've seen before, that to solve an equation with fractions in it, you're going to multiply by the LCD. Okay, rather than trying to get a common denominator or anything like that, you're just going to multiply the entire equation by the LCD. You're going to clear those fractions to start, and then you're going to solve using whatever techniques you've learned in the past. So let's look at an example. Let's say we have 1/3 plus x over 4 equals 11 over 6. Okay, this isn't actually a rational equation because it's actually linear. We just have a little x here. But we're still going to use the same idea. We're going to multiply by the LCD. So we're starting off with just numbers in the denominator. So hopefully that makes life a little bit easier. So the first thing we want to do is identify the LCD. So for numbers, you've got to look and see what they have in common. So what's the smallest multiple of these? 3 and 4 go into 12, and 6 goes into 12 as well. So our LCD is going to be 12. So we're going to multiply this whole equation by 12. And remember, when we multiply, we're going to distribute. So let me rewrite this. We're going to have this and this. Okay, so we're going to multiply everything. Let me do it on the other side. We're going to multiply everything by 12. Multiply by 12, multiply by 12, multiply by 12. Okay. So now let's figure out what's left over. So the 12 should cancel with all the denominators. That's why we chose it. So 3 goes into 12, and we've got 4 left over. 4 goes into 12, we've got 3 left over. 6 goes into 12, we've got 2 left over. Okay, so what's our equation now? The first one is just a 4. 1 times 4 is 4. We've got x times 3, which is 3x. And on the other side, we've got 2 times 11, which is 22. Okay, so when you multiply by the LCD, you multiply every term by the LCD, and that should clear all of your fractions. Now you should either have a linear or a quadratic, and you know how to solve those. So this one, we just need to get x by itself. So move everything to the other side. We've got 3x equals 18. And then we need to get x by itself, so we do the opposite. We divide by 3. So we get that x is equal to 6, and we can go back and check our answer in the original equation, and the two sides should match. Okay, so we're going to use the same idea for rational equations. We're going to multiply by the LCD, and we're going to clear all the fractions. So let's take a look at another one. All right, let's say we've got 3 over x minus 2 minus 4 over x equals 1/2. Okay, so the first thing that we need to do is we need to identify the LCD. So we need the denominator that all of these will go into. Okay, we don't need to factor because there's nothing to factor here. So I need a denominator that will have x minus 2, x, and 2. Remember, 2 and x don't have anything in common with x minus 2. X minus 2 only matches with x minus 2. So I'm going to need all of these denominators. I'm going to need a 2, I'm going to need an x, and I'm going to need an x minus 2. Okay, so I'm going to multiply this whole thing by 2x, x minus 2. All right, so we're going to distribute that to every term. We're going to have 3 over x minus 2 times x, x minus 2, minus 4 over x times x, 2, I left off the 2. 2x, x minus 2. Oh, I left the 2 off here too. Sorry about that. Okay, we're multiplying by the common denominator. Equals 1/2 times 2x, x minus 2. Okay, so like before, you should see that every single term is being multiplied by our common denominator. Remember, whatever you do to an equation, you've got to do to both sides. Okay, so now let's go through and see what cancels. All of the denominators should cancel out. Okay, so here, the first term, the x minus 2's cancel. In the second term, the x's cancel. And then in the last one, the 2's cancel. Okay, so all of the denominators should cancel out. What we're left with here is 6x minus, I've got 4 times 2 times x minus 2. So I'm going to have 8x minus 2. I'm going to distribute that in 2 steps. And then here I've got 1 times x, so I've just got x, x minus 2. All right, so we're trying to get x by itself. We need to do a little work here. We're going to have to distribute this -8. So we're going to have 6x minus 8x plus 16. And we're going to have to distribute this x squared minus 2x. We can combine like terms on the left. Negative 2x plus 16 equals x squared minus 2x. Okay, now when you see this x squared in an equation, remember back to one of our previous videos, to solve this, we're going to have to move everything to one side and factor. Okay, so our last example, we just had x. We could get that by itself, but this time we've got an x squared. We're going to have to move everything to one side and factor. So I'm going to add 2x to both sides. That's going to cancel there. And it's also going to cancel here. So my x term is gone. And then I'm going to move 16 to the other side as well. I've got 0 equals x squared minus 16. We can factor this by as the difference of two squares. So sum and difference. Okay, so this is x squared, this is 4 squared, so it factors as x plus 4, x minus 4. Let me bring this up over here because I'm running out of room. So I've got 0 equals x plus 4, x minus 4. And I've got something times something equals 0, so I can break this up. I've got x plus 4 equals 0, x minus 4 equals 0, and I can solve this. So I get negative 4, and I get positive 4. Okay, so those are our two answers. Now we've got to go back to the original equation and make sure that this is part of part of our domain. We've got to make sure that it's allowed in the original equation. Okay, so if I put negative 4 right here, negative 4 minus 2, that's not 0, that's okay. And if I put positive 4 right here, I get 4 minus 2, which is also not 0, so that's okay. Remember, if we get 0 in the denominator, that's not allowed. Okay, and I can put positive and negative 4 right here, and I don't get 0, and then this one's just a 2, so it's never 0. All right, so we've got to go back and check our denominators and make sure that both of these solutions are allowed, and they are, so we can keep them both.